Let's talk about logarithms and give some introduction before we make the definition. We can take logarithms in some base of some numbers. And the way the logarithm works, if the number happens to be a power of the base, then we get the power. We would say that the logarithm in base 2 of 8 is 3. Or more shortly, logarithm 2 of 8 is 3. We also see that in a way we can cancel out the logarithm and the 2 from here to obtain 3. In the same way as the square root and the second power cancel out. This cancellation is because the logarithm is the inverse function of the exponential function of the power of the base. Why do we need logarithms? If we have a logarithm in any base of some number b to power number c, it happens that we can take the power out from the logarithm. This allows us to solve equations such as 2 to power x is 3. We take the logarithm of any base, let's say 5, from both sides. Now we can take the power x out from here to obtain this equation, and now dividing by the logarithm 5 of 2 we get that x is this number. Here it does not actually matter which base we use. We could have used the base 17, for example. We would have got the same result. So the point is that logarithms allow us to solve exponential equations. Why would we want to solve equations like this? For example, you might have in your account 1000 euros and the bank gives 2% of interest in the end of the year. We can ask that after how many years your investment has doubled. Your investment increases by a factor 102%, that is 1.02. So after 1 year you will have 1000 euros times the factor of money, 1020 euros. After 2 years you will again multiply by the factor and your investment gains this time a little bit more than 20 euros. After n years your investment is this much and we would want this amount to be 2000. So we would like to solve this equation. we can take a logarithm on both sides. Let's take a logarithm of base 5. We can shift the power out from the logarithm. And we obtain n like this. You can type the answer to the calculator and you will get about 35. So after 35 years your investment has doubled. In this calculation we did the calculation by using the logarithm of base 5. We could have used the logarithm of base 17 and we might ask that what is the best base. Well, the most common ones are logarithm of base 2, that is sometimes denoted by LB, logarithm of base 10, that is sometimes LG, logarithm of base E, where E is 2.718. This is usually denoted by the natural logarithm. These have some different advantages. This is very natural for computers. Logarithm of base 10 is very natural for humans. We calculate usually by decimal numbers, so it's very convenient that if we have a logarithm of base 10 out of, let's say, 5 million, the 6 zeros here will be transformed into 6. That's why the logarithm of base 10 is very handy. There are also some other advantages. Then why this natural logarithm is sometimes handy. It has good properties. In formulas. For example, in our example calculation we could have used the natural logarithm and if we would denote this 2 here by x, we could transform this into this kind of equation. Natural logarithm of 2 is about 0.7. Then we have the property that natural logarithm of 1 plus some number is about that number when the number is small. Therefore, natural logarithm of 1 plus x over 100 is about x over 100. We can substitute it here and multiply both the numerator and denominator by 100. We get 70 over x. And if we plug in that x is 2, we get 70 over 2, which gives 35. The point here is that this beautiful formula works best for the natural logarithm. As a conclusion, a logarithm is the inverse of an exponential function. Perhaps the best formula of logarithms is this one, which allows us to solve exponential equations which are related to banking, radioactive decay, and many processes. And you can use a logarithm of any base. Perhaps in the next video we talk about the definition of a logarithm and some of the formulas.